Section 3.3, Types of Statements, Video 3. Before we get into De Morgan's laws, I need to warn you about an error in the textbook. It's in the hard copy of the book, which makes me think that it's also in the electronic copy of the book. It's on page 126, where they list De Morgan's laws for logic. In the textbook, both of these statements start with they talk about being logically equivalent when they should talk about negations. So warning. On page 126, under De Morgan's laws, change is logically equivalent to is the negation of. I just got finished filming the first version of this video, trying to negotiate that in my mind until it finally dawned on me that what's in the book is actually wrong. So I'm going to correct it right now. So let's talk about negations of conjunctions and disjunctions. Let's talk about a statement of the form and. Let's say I say the statement, I have a dog and I have a giraffe. You would probably think I'm lying and you would be right. But what's the negation of I have a dog and I have a giraffe? Is it I don't have a dog and I don't have a giraffe? Actually, it's not. Because in order for me to be lying when I say I have a dog and I have a giraffe, I only have to lie about half of it. Because remember, an and is true only if all of it is true. So for an and to be false, any of it has to be false. For an and to be false, either the first part is false or the second part is false. So the negation of P disjunction, the negation of P conjunction Q is negation P disjunction negation Q. And vice versa with disjunction. If I said I have a dog or I have a cat and I was lying, that would mean I don't have a dog, negation P, and conjunction, I don't have a cat. Both of De Morgan's laws also have an equivalent version in sets when we did the first test material. So if you want to go back and compare it to that, I would invite you to. But I also want to show you a way to remember both of these by just translating the negation of into words. When I say the negation of P conjunction Q, I could write a negation symbol, open up some parentheses, and inside write P conjunction Q. I'm kind of abusing the use of the equal sign, but we'll let it slide. This looks like the distributive property, and it almost is, in the sense that you can distribute the negation to the P and the Q. But in a bizarre sort of way, you'll also have to distribute it to the conjunction and take its, well, opposite. Now, conjunction and disjunction aren't actually opposites, but this is just a gimmick for remembering De Morgan's law, that the negation of a conjunction is the disjunction of the negations, and it works on both of them. The second one would be the negation of a disjunction, and again, it looks like a distributive property, so you can distribute it if you also distribute it to the disjunction and take its negation of disjunction. Again, it hurts me to say that because conjunction and disjunction can't be negations and not even statements, but it's just a gimmick. Distribute the negation to everything, negate the P, change the symbol to conjunction, negate the Q, and that will give you the other version of De Morgan's laws.